All right, so moving right along, we're going to launch into our next two problems here. All right, and so these we're seeing. Hopefully, you're looking at this and you're seeing some more of the tangent, cotangent stuff, and all of that. So we're gonna mess about with this. All right, so let's put a little line here so we don't infringe upon that territory. So this one right here, I think the first thing we should do is let's simplify this and this and then see where that puts us. So if we go sine squared theta minus, well, let's write cotangent. Let's write everything we can in terms of sines and cosines. That's always like my go-to, at least for getting started. All right. So cotangent is cosine theta over sine theta, and tangent is the opposite. It's sine theta over cosine theta. Now, at some point, you're going to start seeing things next to each other and go, I know those make one, and you won't have to write them out. Like you'll recognize that, hey, cotangent and tangent always equal one when you multiply them by each other, right? So if you do that, cotangent times tangent, sine and cosecant always make one, and cosine and secant always make one. So the sooner you can kind of connect that together, that's going to make your life a lot easier. All right, so we know we're going to have something work out nicely up here. That's going to give us one up top. And now for the bottom, cotangent, we just went over cotangent. That was the cosine over sine, right? Cosine over sine times sine of theta, right? Well, in the sine of theta, we can just put over 1, and then you'll see there that our sines cancel. And so this whole simplified expression looks like this. So cosine squared theta minus 1 over, or sorry, sine squared theta minus 1 over cosine theta. Now, this is a little scary, all right? And so I'm going to show you why. Because I'm thinking, oh, I'm going to use this sine squared plus cosine squared, use this to substitute and put cosine squared in. But the thing is, if I solve for cosine squared, right? So in other words, if I move the sine squared theta over, right? I have sort of something that looks like this, but it's inverted. It's in the wrong order. And so whenever you see things like that in algebra, there is there's two things you can do. So the first thing you can do is you can go back to this, and instead of solving for cosine squared theta, um, move the 1 over and swap out the cosine squared theta and the -1, right? If you do that, so what that's going to, I am going to infringe upon the area, but they'll forgive me. So if I do that, I'm going to have sine squared theta minus 1, because if I subtract 1 from both sides, right? And then plus cosine squared theta equals 0. And then we're going to take this and we're going to move this guy over there. So you'd get sine squared theta minus 1 equals negative cosine squared theta. So that bothers a lot of people, right? I don't know why, but it does. But that's actually what we're going to be using. Now, the other way to think about that is if I have this and I know I want to have this, you recognize that basically, hey, they're the same terms. It's just that one's positive in one and it's negative in the other one, and one's negative in one and it's positive in the other one, right? So if that's the case, what you can always do is you can divide everything by -1, right? And you get negative cosine squared theta. And what that -1 does when you divide it by this is 1 divided by -1 is -1. And then negative sine squared theta divided by -1 would give you positive sine squared theta, which is sine squared theta minus 1. All right, so they'll both get you where you need to go, right? Whichever works better for you. I think this makes a little more sense, right, than just kind of thinking, oh, I'm going to randomly divide by -1. But that's kind of how I was taught, like way back in the day. So that's how I remember it. But if that doesn't work for you, this is kind of the more intuitive, sensible way. All right, so let's swap this out with negative cosine squared theta then. Okay, and we can do that. These can be negative. All right, and then what you're going to get is this one is going to cancel with one of these, and then your answer is going to be negative cosine theta. And I hope that doesn't make you too uncomfortable, but that is how that works. So let's get rid of this. We're going to clean this up a little bit. Okay, and now I think what I'll do is I'll learn from my past mistakes, and we'll go over a little bit for this one. And so we got cosecant squared theta minus cotangent squared theta. So what I thought about when I did this one is, oh, well, I know I have these other identities that I can use, right? And so the other identities, if you remember them, so we've got our first one, right, which is sine squared theta plus cosine squared theta, which is 1. And then we have the 1 plus cotangent squared theta. And because there's a sign on the bottom of the cotangent squared theta, that tells me the 1 over on the other side is going to be cosecant, because that's the identity, the remaining identity that has sign on the bottom. And then that means that you just put the remaining 2 in the other one. If you can figure out one, you can figure out the other. Right? So, and tangent and secant both have cosine in their denominator. So that's what we go with. So I'm going to take this cosecant squared theta because it's positive and I don't have to do any screwing around. And I'm going to substitute it with this. So I'm going to go 1 plus cotangent squared theta. And then before I do anything else, hopefully you recognize, well, wait a minute, I'm subtracting cotangent squared theta right after that, which means that they're going to nicely kind of eliminate each other, which is sweet, all right? And then you have tangent times cosine. So tangent, we write everything in terms of sines and cosines. So sine over cosine times cosine theta over 1. Your cosines get eliminated, and you are left with 1, because 1, these just eliminate each other and become 0, right? And you're left with 1 over sine of theta, which is cosecant. So this whole ugly mess is just another way of writing cosecant theta. Okay, so hope that was kind of a little fun for you, maybe a little nerve-wracking, but you know, I kind of like these because they're sort of like puzzles, you know, and I think if you think about them that way, and maybe some of you hate puzzles, so you're like, no, I don't want to think about it that way, and I get that too, but that's how I think about them, and we're just using these three main identities, and then the ones we learned and are using heavily from the day before. So good luck with these. The homework video will be coming out after this, so we'll see you. Excuse me. Nice way to end the video, huh? See you in the next one.